Now we move on to section 4.3, Objective 2, which is performing residual analysis on a regression model. So recall from section 4.1 that there are a lot of things you have to do in order to make sure to test whether a linear model is valid for your data set, a linear relation is valid for your data set. So one thing we did was we learned how to look at scatter plots, and we also learned how to graph those in Excel. We actually did the graphing part in section 4.2, but nevertheless, we know how to graph them. Oops, not there. There. Haha, scatter plot. Okay. Then we also learned how to check the critical value. That was way back here. There it is, right there, with this table thing, and then you had to make sure your absolute value of R was larger and all that good stuff. Okay. So now we want to be able to do something called residual analysis. We're going to look at the residual plot. Now remember, we already know what residuals are. Just on a side note, there are some other things that you can do, but we're not going to cover them, at least as far as I know. They're in chapter 14. So if you're interested, you can check out chapter 14. All right, so we learned what the residuals are in section 4.2. They are the observed values minus the predicted values. So suppose a scatter plot with a linear regression line drawn looks like this. Now remember, there's the observed real life off the line, and then the line value that goes or is associated with it is called the predicted value. And the distance between them is your residual. So you can have negative residuals, you can have positive residuals, right? So you have negative and then a bit more negative. That's why this dot's lower, and then this dot's a little bit more lower, and then above, and then really far above, and so on. And that plot is called a residual plot. It sort of takes this diagonal line out of the equation and turns it so that it's horizontal and just talks about distances. That's it, right? We're not looking at anything else other than your x value and what was the distance from the line. Okay, we are not going to be drawing residual plots by hand. We're going to have computers draw them and or we'll analyze pre-drawn graphs. I should say, and I just changed this, so it says we will make them with StatCrunch. You can make them with Excel if you have some add-ins, but we will make them with StatCrunch or we'll analyze the graphs drawn by the computer. So I can have different computer programs draw them for us. Okay, so first thing we have to determine is whether a linear model is appropriate or not. Okay, so I've got this data right here, which is what they have is they have temperature probe right next to a portable heater, and then they turn off the heater and then they clock the temperature as it changes. So I'm going to have to go to Excel or StatCrunch. Let me go to StatCrunch. Bring it over. All right. And just like on a test, what you can do is you can make it so the window's kind of smaller, and then you can put these in. So this is time, oops, I have caps lock on, time in seconds. I really should have. There we go. And then temperature. Oops. Temperature in Fahrenheit. All right. Then I'll type. So there's the seconds, and here's the temperature. I don't know why I'm making you watch me do this, but okay, sorry about that. A little boring. All right, so I've got this in there now. And now I can make it bigger because I don't need the rest of that. Stat, regression, simple linear. We've done this before. So temperature, or excuse me, time, then temperature. Next. Skip this page. Do you want to save your residuals? It'll make a list of them for you if you want. We don't really need that though. Next. Aha. So do you want to plot the fitted line? Right, that'll make a scatter plot with the line on it. That's always good to have. And this is the one you want, residuals versus x values, because we're leaving the x values alone and we're doing residuals. Now notice there are all these other ones. There's tons of ways you can plot your residuals. So, but I'm doing the residuals versus the x values. That's the one our book does. All right, click next. This I can ignore. It's fine. Calculate. All right, so there's the info, which I don't really need any of this stuff. It's nice to know. And you can see how high, look at that. Well, actually, I guess we do need that because we need to know how high this was. It's that high. So actually, I can copy and paste, and I will copy Oh, you know what I'll do? I'll put this in my Excel spreadsheet since you have to turn this in. So this was 4.3, example 4. All right, and then I'm going to copy and paste my data in. So it doesn't hurt to have Excel have it anyway. Copy, and then paste. All right, and then I'm going to go get that mini tab, or excuse me, that StatCrunch output. It's over here in the little Java, right there. And actually, I'm going to do the whole thing. I'm going to copy the whole kit and caboodle and paste it in. Because you never know, I might want some pieces of it. And then we go back to the Java. It's a little cup of coffee thing right down there. Get it, Java. Press Next. There's my scatter plot. So I'll paste that in. You can make it smaller. You just kind of move your cursor up here to the top left corner and drag it down. So there, it's a smaller graph, a little bit more manageable. And then if I go back to the Java cup and say Next, there's my residuals. All right, now you might notice there's a problem here. Now, let me get this down to a manageable size here. There you go. And actually, this is what the problem wanted anyway. So let me get all this. All right, so there's my equation. So let me go back to, there it is. So my scatter plot's right here. And then my residual plot is right here. Copy and paste. And then the question becomes, was a linear model appropriate? Now I want us to look at a couple things. And let me also grab this real quick. It appears that a linear model was appropriate because R is equal to negative 0.9966 and the scatter plot looks good. However, right, because look at this R. This R is really high. Okay. Looking at the residual plot, though, you can tell that it wasn't appropriate. Sorry, I just have to change my formatting here for a second. So if you look at the scatter plot, you can tell that it's no good. The reason being because if it was any good, then you wouldn't have this pattern that you see to your residuals. Hold on one second. There we go. Okay, so, but a linear model was not appropriate for this data. It's irrelevant how large R was because the regression, or excuse me, the residual plot has a it has a pattern to it. It doesn't really matter. The most common patterns you'll see are kind of U shapes, like upside down U or up faceward up U. So, but if it has a pattern like that to it, that means that a linear model was not appropriate for this data. I don't care that your initial reaction is like, oh yeah, it looks fine because R is so great. Yeah, well, R being great alone does not cut it. The scatter plot alone does not cut it. You need all these things in conjunction to work. So you need it to have a good scatter plot, you need to have a high R value, and you need a residual plot that doesn't make this U pattern. The U pattern thing is bad news. All right. So that's what we know. We are, oops, let me just put up here. So if the residual plot shows a discernible pattern, that implies that linear regression was not appropriate for that data set. And that's what we just showed. That residual plot had a pattern. It's no good. What about this one? That's the other kind of problem you can have with a residual plot. You don't want to see a horn shape. It's called heteroscedasticity. I love that word. So if you see this kind of horn shape thing, it can go either direction. It can go from small to big or from big to small. But if you see that, which we do in this case, a linear model is not appropriate for this data because of the horn shape to the residual plot. Okay, so just keep in mind what this means. This means that all of these things have to work in concert. You have to have a good scatter plot, a good R, and a good residual plot. And if any one of those breaks down, then it doesn't matter. The rest of it is garbage. So if you have a bad residual plot, then all that other work, the slope, the correlation coefficient, and everything else is just worthless, right? And now the computer won't know the difference. I mean, StatCrunch is going to run this analysis no matter what you do, right? It's going to give you these answers. So you have to look at it and go, oh yeah, so you gave me this high R value, but it doesn't make any difference because my residuals look like that. And that is not good. Okay? All right. I like the highlighting thing. That's kind of cute. All right, so let me go back to this. All right, so let's just make a note to ourselves, right? We need to have a good scatter plot. By good, I mean it's got to show a linear relationship, a high or a good R value, or R correlation coefficient, and we need the residual plot to not show a pattern or a horn shape. Oh, I guess I should say, what do we need these things for? In order to show that a linear model was appropriate for a data set. These are the things we need. So we've got to have 1, a good scatter plot, 2, a good correlation coefficient. Remember, that could be high or low. It's just got to be close to 1 in magnitude, right? Like negative 0.9 is good. And we need the residual plot to not show a pattern or a horn shape. Any one of those things breaking down causes the whole thing to not really be linear. All right, we're done with residual plot analysis. We will move on next time to outliers. See you then.